Okay, so looking at the zero exponents. This is probably the easiest, in my mind, the easiest property that we're going to talk about. It says anything raised to the power of 0 is going to be 1. Whether it's a variable or a number, it's going to equal 1. Now, if it's within a term, is it going to change this whole thing to 1? No, just the exponent of 0 and its base. So that's going to end up, go ahead and write it like this so that you know, maybe you'll be able to remember where the 8 to the power of 0 went. And then 1 times x to the 4th is x to the 4th. And so going to the one below, what is that going to turn into? X cubed. Because you're going to have x cubed times 1. X cubed times 1 is going to be x cubed. Whenever you're done with that, go down to page 2, which I believe is the bottom right box of that page. So going down here, this is probably a new one. This may be one that you didn't talk about in Algebra 1. Maybe you did. But it's one that you're going to run into a lot. So it says that negative exponents are not simplified. So that means whenever you have your final answer, you don't want to have negative exponents in it. To simplify, change the sign of the exponent and use the reciprocal or flip it. So the way I explain this is if you have a base with a negative exponent, move it to the other part of the fraction and make the exponent positive. Okay? So on this first one, you've got x to the power of negative 2, which is over 1. You're going to move the exponent to the denominator and make it positive. The example below it, it has a negative exponent that's in the denominator. You would move it to the numerator, make the exponent positive, and that simplifies it. Now you don't have to write it over 1. I'm just showing you that it's going to the numerator. So on the first one that's not answered, 5 to the power of negative 3, that is going to turn into 1 over 5 cubed. Okay, so now, Keenan, what would the next one be?
1 over 5 cubed.
Negative 5 cubed. The base can be negative. The exponent cannot. So make sure that you're aware of that. You can have a negative base, that's fine. It's the exponent that you're concerned about. And then the last one, and this is more likely what you're going to run into, is stuff like this. I would go through there, identify what all has a negative exponent, and then just move it to the other part of the fraction. So first, does the 2, does it have a negative exponent?
Yes.
No. It is 2 to the power of 1. Does the x have a negative exponent?
Yes.
Yes. Does the y?
No.
Does the 4?
No.
Does the z?
Yes.
So the x and the z are the two things that I need to move. Everything else can stay the same. So in the numerator, I've got the 2. The y, it's happy where it's at. The z was unhappy in the denominator, so I move it to the numerator. And I go down here, I've got 4. And then the x had a negative exponent in the numerator, so I move it down to the bottom. Questions on this? Because you'll see this property a lot. Okay, let's go to this one right here, page 3. This isn't necessarily a property, it's emphasizing the parentheses in a very, very common mistake that people make in here. So, that first line, it says 3 to the power 4. The exponent is what? 4. The base is what? 3. Which most of you are probably fine with this one. 3 to the 4th, that's the same as 3 times 3 times 3 times 3, which is 81. Going to the second line, negative 3 to the power 4. The exponent is what? The base is what? Negative 3. And so that would be negative 3 times negative 3 times negative 3 times negative 3, which is positive 81. On the last one, you've got negative 3 to the power of 4. The exponent is what? The base is what? Positive 3. Okay, and that's the mistake. That's why this little page is here. Okay, the negative is not part of what is being raised to the power of 4. So if you look down here, this right here is represented by this, and then it just has a negative up front. Okay, and then 3 to the power of 4 is 81, and then you've got the negative in front of it. This right here is where the mistake happens, because I'll say raise negative 3 to the power of 4. People will put the second one in the calculator when it should be the first one, and they tell me negative 81 instead of positive 81. So you've got to be careful whenever you've got parentheses in the problem. Next, go to page 4, which I believe is in the top left of the second page. So talking about adding and subtracting. This one should be pretty simple because all you're doing is combining like terms. So let's make sure that we're clear on this. These three terms, are they all like terms? Yes or no? Yes. Why? Because it's all x and it's all x to the power of 3. Okay, they're all x cubed. So I just add them up. What is 9 plus 3 plus 2? 14. That is correct. Nick, what'd you get on the third one?
2x squared plus x plus 8.
Plus, what was the middle term again?
X plus 8.
Okay, it should be 4x. Going to the one below, multiplying. So on these, whenever you're multiplying like bases, and they have to be like bases in order for you to do this, you're going to add the exponents. Just make sure that you know your coefficients. So in the example they give you, 4 and 2, you're still going to multiply those coefficients, but you're going to add the exponents. And I would take these things one at a time. So first I would do the coefficients, and then I would do the variables. So on the first one, what is 4 times 3? 12. What is x times x to the power of 4? X to the power of 5. Go ahead and do the next one. So looking at this one, again, I'm going to do the coefficients first. So what is 3 times 1 times 2? 6. Then I've got x to the 7th, x squared, and x cubed. So that is going to give me x to the power of what? What'd you say, Parsa? 12. And then Logan, what is y to the 5th times y?
Y to the 6th.
Y to the 6th. Now I want you to do the next two. Okay, looking up there. raise your hand if that's what you got on those. Okay, what is the one thing you can't have in your answer? The negative exponent. So looking at that first one, does one of those two have a negative exponent?
Yes.
Which one?
X.
X. So I'm going to take the negative exponent and its base, and I'm going to move it to the denominator. So I'm going to have y to the fifth over x squared. I want you to move all of the correct things on the last one. Okay, looking at, so on this one you should have gotten, again, the 6 can remain negative because it is a base. It's not an exponent. And then so in the denominator you would have x z squared. Alright, now we're actually going to go to 7, which is on that same page. I think it's just a more natural progression to go from multiplication to division. So common sense would tell you that if you're multiplying like bases, you add the exponents. So that means if you divide like bases, you're going to do what to the exponents? Subtract them. So here's your example of 8 minus 4, which gives you x to the fourth. Going to the next one. You're still going to divide these coefficients. Okay, so I would do 1. I would simplify this one. Now, some confusion comes around whenever I do 7 minus 5, and then, so it's x squared. But do I put it here, or do I put it here? In the numerator or denominator? Not necessarily. You'd put it in the numerator. And then, if that ends up being negative, you would then move it down to the denominator. Okay, so look at the next one. I'm going to go ahead and do 12 divided by 3, which is 4. And then I've got 1 minus 5, which is, so x to the power of negative 4. I've got y to the fourth divided by y squared, so 4 minus 2 is 2. And then I've got z squared divided by z, 2 minus 1 is 1. And then now I'm going to deal with the negative exponents, which is only the x. So this is going to give me 4y squared z over x to the fourth. That's what you should have gotten on the last problem there. I have no idea where I got negative 6. So I was looking at the 5 on.
Where do you get Z?
So that would be negative 1. 1 second. Okay, so on the 10 and the 4, for my x's, I've got negative 5 and 5. So I've got my numerator minus my denominator, which is negative 10. For the z's, I would have 1 minus negative 3, which is 1 plus 3. And that would give me positive 4. Go to the other page. Go to, I think it's labeled page 6. The power to a power. So it says, when raising a power to a power, you distribute the exponent. The base stays the same, but you multiply it. So on the first example that they give you, this is pretty basic. You've got x to the fifth to the power of 6. 6 times 5 is 30, so it's x to the 30. The second example has something that a lot of people make mistakes on, and they forget to bring that exponent to the coefficient as well as the variables. you've got to remember to do that. So on this first one, the very first thing I'm going to have is 3 to the power of 5. And then after that, I'm going to distribute that 5 to the exponents, and now I'm going to multiply. So 3 times 5 is 15. 2 times 5 is 10. 4 times 5 is 20. Bless you. And then I would go ahead and do 3 to the power of 5, which somebody throw that in your calculator and tell me what it is.
243.
2 what?
243.
243.
Mm-hmm.
So that would be your answer. Let's go ahead and do the next one. So that first one, again, I'm going to distribute that. So I've got 3 times 4, which is 12. I've got 2 times 4, which is 8. Okay, and again, I need to bring that exponent to the coefficient. So what is negative 2 squared? Positive 4. And then I've got 2 times 1, which is 2, so x squared. 2 times 3, which is 6, so y to the 6th. And then I want you to finish this problem. So multiply those two. And we'll do the next one together as well. But go ahead and finish that problem out. So there's your answer for that one. Now, how I would do this next one, whenever you got power to a power, and the highest power is a negative, you can do this a couple different ways. And the more of these problems you do, you might realize that some people do these properties in different orders than others. So the first thing we could do is we could put this over 1 and just make that positive 4. Alright, but normally, again, kind of what I told you earlier, I'm always going to do that negative exponent last. So I'm going to take that negative 4 to the 4 parts of that the term that's in there. So I'm going to end up with 2 to the power of negative 4, x to the power of 8, y to the power of negative 12, and z to the power of negative 4. And now I'm going to go through there and I'll find all of my negative exponents, which 2 to the power of 4, I'm going to move down, and that's going to be 16 whenever I do that. The x is fine where it's at, and then the y and the z need to go down to the denominator. And then this last one, it may look the hardest because it's a power to a power to a power, but it's probably actually the easiest one on here. If you work from the outside in, I think it's easier than doing it the other way, which again, if you work from the inside out, you'll still get it correct. But if I do this power to a power first right here, so 2 times 3 is what? 6. So I end up with 3x squared y all to the power of 6, and go ahead and finish that problem.
Yeah, also, we're only going to
Okay, somebody tell me what 3 to the power of 6 is.
729.
729. Chris, turn around. Turn around. Okay, so that's what you should have gotten. 729.
Oh,
3 to the power of 6. Okay, go back. Now go up to the top left. So these are the problems you're going to see. And I want you to work through these. The only thing that you're going to see on these 4 problems that we didn't see this exact situation. If you look at the one on the bottom left, where you've got a fraction raised to a power, you're going to take that -5 to everything in there and then go from there. So I want you to go ahead and attempt those 4 problems.
I wouldn't swear a lot on that.
So to do this, what I want you to do on the back of one of the pages, the one that has number 8 on it, roughly kind of know where the lines to that box is so you don't cut these out. And I want you to write these problems. Go ahead and draw that box while I find where this is at. With those radical functions, it is going to entail having to change, sometimes having to change it from radical notation to having an exponent. Okay, normally, or the majority of the time, ending up with a rational exponent. Okay, so if you have something raised to the power, if you have the square root of something, does anybody know? Let me rephrase that. If I have the square root of x, that is the same as x to the power of what? Does anybody know that? Not 2. That would be the opposite. So what's the opposite of 2? Or no? 1/2. Okay, so if you have the square root of something, you raise whatever is underneath there to the power of 1/2.
We need another sparkler.
Okay. So if I'm taking the 4th root of something, then I'm going to raise it to the power of what? 1/4. So I would have x squared to the power of 1/4, and now that is your power to a power property. So 2 times 1/4 is 2/4, which is 1/2. On number 3. So on this one, I would have x cubed to the power of what? 1/4. 3 times 1/4 is what? 3/4. So now going down to number 4. Taking the cube root of something is going to be the same as raising it to the power of what? 1/3. Now, whenever I do this, now I'm going to have 8 to the power of 1/3. In my mind, that doesn't process, if you're asked to do this kind of stuff, my mind doesn't process that as easily as it does trying to figure out what the cube root of 8 is. Alright, they're the same thing, but if I have the cube root of 8, what is that going to be? 2. Okay, that is doing the exact same thing as 8 to the power of 1/3. And then I have power to a power, so what is 6 times 1/3? 2. Now, that one comes out nice and neat. On the next one, you would have 16x to the power of 8 to the power of 1/3. If it does not come out nice and neat, just leave it written as 16 to the power of 1/3. The majority of the problems we give you, they will though. But in the case that it does not, leave it like that. And then 8 times 1/3 is going to be 8/3. And then the very last one. So I'm going to have x squared y squared to the power of what? 1/2. And whenever I do my power to a power, I'm going to end up with what? Just xy. Because 2 times 1/2 is 1.